In this video then, I'm going to be looking at a rates of reaction question. So the rate of reaction at AS level is not too dissimilar from that at GCSE level. So there's a whole topic on the rates of reaction at A2 in the second year of the A level course, which is far more complicated and introduces a whole bunch of new stuff that you wouldn't have seen before. However, for the AS component, the rate stuff is not overly complicated, I should say. It's very much GCSE based. However, there can be some nasty questions asked on it, and I'm going to go through one of those in this video. So I use this question an awful lot if I'm trying to get students to really think about how they're putting their answers together, because there's a lot of stuff going on here. So let's have a quick look. They're carrying out a standard gas collection practical, which is really nice. Okay, so they've got gas syringe, conical flask. They're going to chuck some, hydrochloric acid in with some zinc, collect the gas, and and then measure it. Okay, so essentially, there's three parts to this question. Okay, now I'm just going to highlight the bits you need to actually do here. Now, it's really important. They're trying to determine the initial rate of reaction. That's what they're trying to work out. And you have to decide how they're going to carry out the experiment, explain how the results can be processed graphically, and a really important bit is they put the word calculations. Now, if you're not doing any calculations when answering this question, then you're doing something wrong. Okay, that's a big hint right there. So it's telling you that there's going to be some calculations in this question. And you might think, well, hang on, it's just surely outlining how they can carry the experiment is just a method, right? Well, not quite, because they've given you some more information in the question. They've told you an exact amount of hydrogen that they want to collect at room temperature and pressure. I'm using an excess of zinc. That means that we've got to be a bit more specific. Now, at GCSE, you may get away with it. You may get away with just saying, add the zinc to the hydrochloric acid, collect the gas, yada, yada, yada. You can't do that at A level. You're expected to have a higher working knowledge of what you're doing. So that long gone are the days where you can write those methods just in words. Okay, they've given you a lot of specific, you know, equipment and values here. You've got to tell them how they're going to calculate, how they're going to run this reaction in its entirety. So first of all, I'm going to calculate how much I'm going to need. Because if I want to collect 72 centimeters cubed of hydrogen, that's quite a specific number. You need to work out how much zinc and hydrochloric acid you need first. You can't just say weigh out the zinc and measure some hydrochloric acid, because it won't give you 72 centimeters cubed. You need to tell me how you're going to get 72 centimeters cubed, exactly. So let's have a quick look at how we're going to work this out then. The key part here is it's at room temperature and pressure. So we can work this out very, very easily. So let's take a quick look then. We've got our reaction. I'm going to write down the equation for the reaction because I think it's important to know what the reaction is. So ZnCl2 plus H2, because we know it's hydrogen gas, and we know we're going to need two of these and two of these. Did I just do that? Did I just do that? Honestly, what is wrong with me? That is, oh God, that's actually embarrassing. Right, moving on then. We've got our equation, which I have now balanced correctly, rather than just having an absolute brain fade like I just did. Now, we need 72 of hydrogen. Okay, we need 72 centimeters cubed of H2. That number is meaningless to us. However, it is at room temperature and pressure. So the first thing you should be doing right now is calculating how many moles that is. Okay, centimeters cubed is not a good measure to work in. I much prefer working in moles. So let's work it out then. Centimeters cubed. So in terms of moles, okay, so the moles of H2 is going to be 72 centimeters cubed. Okay, so we're going to use our molar gas volume. Okay, so we know that 1 mole of a gas at room temperature and pressure is 24,000 centimeters cubed. Therefore, if we want to work out the amount of moles that we have of H2, we simply divide by 24,000. So divide by 24,000, and we get 3 times 10 to the minus 3. Nice and straightforward. That's how many moles of H2 we've got. Now, that means that we need that many moles of zinc, because it's a 1-to-1 ratio. And so we'll just put there, it's a 1-to-1 ratio. So look at the stoichiometry. So if we've got 0.003 of H2, it's 1-to-1, so 0.003 of zinc. And because it's a 1-to-2 ratio, we're going to need 0.006 of HCl, because it's the 1-to-2 ratio. We've got twice as much HCl. Now, that means that we can work out both the amount of zinc and HCl required to carry out this reaction. So the zinc is easy. Okay, zinc is just a metal element. We've got that many moles. So for the mass of zinc, okay, mass of Zn, we're going to work out mass by doing moles times molar mass. So we're going to do 0.003 times 65.4. I'm doing this off the top of my head. I don't have a periodic table. I think it's 65.4. That's what I'm going with. If I'm wrong, I apologize, but you get the idea. It doesn't really matter anyway. Yeah, if that's not the molar mass of zinc, just sub in the correct version. So yeah, 0.1962 grams is what you require, and therefore, if we are using an excess of zinc, okay, then we simply need to weigh out more than this number. So when we come to weigh out our zinc in our method, we simply need more than 0.1962. Now, for the hydrochloric acid, we've got ourselves a bit of a dilemma, because hydrochloric acid is a liquid, which means for our hydrochloric acid, okay, we've got the moles of HCl. So moles of HCl is 0.006. However, if we're going to do this as a method, we need to work out a volume and a concentration. Well, we can't do that because we only have one number. How do we work out the volume if we don't have the concentration? And this is where people normally fall down. They get this far and they go, oh, what do I do now? There must be a trick. Well, there is no trick, because you're planning the experiment. So you can tell me how much hydrochloric acid you want to use. You can tell me how much you want and work out a concentration for it. So, for example, we've got ourselves a conical flask. Now, you should know from your own knowledge that most conical flasks are going to be up to 250 centimeters cubed. And in the question, they've told you it's a 100 centimeter cube measuring cylinder. So, if we are using a 100 centimeter cube measuring cylinder, that means the amount of hydrogen has got to be less than 100 to measure it properly. Now, what's a sensible amount of hydrochloric acid? Well, there's no real correct answer to that, and that's why the mark scheme accepts a range of answers here. But it's got to be enough acid so that the zinc can react. So you can't just use like 5, because the zinc won't react in that. You need enough liquid for the zinc to be submerged. So you need to pick a number between 1 and 100 that is a sensible amount that will allow you to submerge the zinc and ensure ensure the HCl fully reacts. So let's say 50. Why not? That's not a bad number. Let's use 50 centimeters cubed. You could use 30, 40, I don't care. Okay, it's got to be a sensible number that you can measure with the measuring cylinder and will ensure that the zinc can react. So you need enough HCl that the zinc will react, and react all of it. Okay, so it needs to be submerged effectively. Now we've worked out concentration. So, concentration is moles over volume. So we'll just do 0.006 divided by 0.05, again 50 over 1,000. And that gives me a concentration of 0.12 mole per decimeter cubed, which is a sensible concentration. It is not too strong, it's not dangerous, that's fine. So that's the mathematics of it. Okay, we've worked out how much we need as a minimum of zinc. Okay, we need to use at least 0.1962, probably about 0.25 to be certain. And then we need to work out the amount of hydrochloric acid, and we've done that. We've picked a volume and we've picked a concentration that makes sense. What we've got to do is write up the rest of it now. So for the method, it's simply measure, let's call it 0.25 grams of zinc on a 2 decimal point balance. Okay, make sure you use specific equipment. Measure 50 centimeters cubed of 0.12 m HCl in a measuring cylinder. Okay, add to conical flask, and then what are the apparatus have we got? So again, stop clock. So we add them in there. Start the stop clock would be a sensible thing to do then. So start stop clock. And then in order to measure the rate of reaction, we need to measure how much hydrogen is produced at a set time interval. So we need to obviously, to determine the initial rate of reaction, we need to know how much gas we're getting at certain times. So that means essentially every 10 seconds, every 20 seconds, measure the amount. So measure amount of H2 every, I don't know, every 20 seconds. Okay, it can be every 10 seconds. As long as it's a sensible interval, you'll get the mark. That's it. So that's the maths. That's the method. Okay, and you can say how long you want to do it for. You can just put until reaction finished, until gas is stopped. You can go as long as you want. Really, it doesn't really matter. Final thing then, how you could process it graphically. So graphically, okay, so you're going to need to plot a graph. So you need to plot the amount. So you need to plot, okay, so time. So what y versus x, you need to plot the amount of gas against time. Okay, or vice versa, doesn't really matter which one. You can draw it out if you want. You just do a graph, just put time. So you put amount of gas. That says amount of gas and time. Okay, you get a graph looks like this almost certainly. Okay, you haven't got to draw it by the way, but it's just showing plot amount of graph against time to work out, again, back to our question, the highlighted bit. So I've done the carry out experiment. I've used all this, I've used all that. I've used my calculations. Now I need to determine the initial rate of reaction. So that means plot amount of gas against time. You need to draw a tangent. Okay, if you remember that from GCSE, draw a tangent at t equals 0 and calculate the gradient. You do not need to do any of this for the question, but you need to say it. Okay, so plot amount of gas against time, draw a tangent at t equals 0, calculate gradient, and you could always put equals rate. That is the rate, okay, or initial rate. That's it, okay, because I've now determined the initial rate of reaction, I've processed them graphically, that's everything. Okay, so a very, very in-depth 6 marker, and this is why I use it against unsuspecting students, because there is so much. It looks on the face of it a very straightforward question, but there is so much you need to make sure you get in your answer. The calculations, ensuring the zinc is in excess, then picking a sensible volume and concentration of hydrochloric acid, then talking about the method, including key points and terminology, and then plotting the amount of gas against time, drawing the tangent, and calculating the gradient. A lot of stuff goes into that question, I appreciate. So, big 6 marker. Going forwards, obviously, you need to be confident in drawing your own tangents on graphs. There are many questions that ask you to calculate tangents on graphs. So, just be aware of that. Okay, I'm not going to show you how to do that on this video because it's very hard for me to draw tangents and things on my little tablet, so I can't really do that. But it is very much a GCSE thing. So that's a big 6 marker on rates. showing you the depth of knowledge you need and how much you need to write in order to fully answer one of these big 6 mark questions.